In this lesson, you'll delve into the different data types available in Elixir and learn how to declare them, print them to the console, and verify their types using built-in functions. Understanding these concepts will enable you to handle data efficiently, prevent errors, and optimize storage and performance in your Elixir programs. Let's get started with the basics. Let's now look at declaring different data types in Elixir and printing them to the console. The code on the left shows how to declare integers, floats, booleans, strings, and atoms. We also use the io_puts function to print these values to the console. On the right, you can see how to verify the data types using Elixir's built-in functions like isInteger, isFloat, isBoolean, isBinary, and isAtom. Notice how we print the results of these checks to the console as well. Let's start with the first data type, integers. Integers represent whole numbers, such as 1, 42, or -10. They are used when you need to store and manipulate numeric values without fractions. Now, let's move on to the second data type, floats. Floats are used to represent decimal numbers, such as 3.14, 0.5, or -2.0. They allow you to work with numbers that include fractions or decimal points. Next up is the Boolean data type. Booleans represent true or false values. They are particularly useful in decision-making and conditional operations in your code, where you need to determine the truthfulness of a condition or expression. Moving on to the string data type. Strings represent text and are enclosed in double quotes. For example, hello Elixir is a string. Strings are commonly used to handle and manipulate textual data within your Elixir programs. The final data type we cover is the atom. An atom represents a constant whose name is its own value, for example, $OK, $error, or $hello. Atoms are used to represent static values and are often employed as keys in maps. If you declare the same atom multiple times, it will always refer to the same memory location. Understanding data types is essential for various reasons. Efficient data handling allows you to choose the best operations and functions for your data. Error prevention is another critical factor. Incorrect data types can lead to bugs, such as performing arithmetic operations on a string. Lastly, optimized storage and performance are vital, as different data types consume different amounts of memory. Proper use ensures efficient memory usage.